the moon travels around the Earth, and depending on its position, in relation to the Sun or other celestial bodies, it produces different lunar cycles, also called lunar months. The best known are Sidereal Month. The word sidereal comes from the Latin sideres, meaning pertaining to the stars. This highlights the fact that the cycle is measured in relation to the stellar backgrounds. Let's imagine we are observing the moon from far away. In order to measure how long it takes the moon to complete one full orbit, we need a fixed point of reference, and for this, we use a very distant star. The sidereal month is the time it takes the moon to travel once around the Earth, measured against a distant star rather than the Sun. This period lasts approximately 27.32 days. Learning about the sidereal month is important, since it shows the moon's real motion through space. It's especially useful for accurate astronomical calculations, such as stellar navigation and celestial mechanics. Synodic Month. The term synodic derives from the Greek synodos, meaning meeting or encounter, in reference to the moon's meeting with the sun in the sky. The sun is also involved in the synodic period. The synodic period is the time it takes the moon to return to the same position in the sky relative to the sun when viewed from Earth. During its full moon phase, the moon completes one full orbit around the Earth and realigns with the sun in roughly 29.53 days. To calculate the duration of the synodic month, we will use the following formula. This represents how many orbits the moon completes per day, using the fixed stars as a reference. This represents how many orbits the Earth completes around the Sun per day. Subtracting these orbital frequencies gives the frequency of the synodic month. By taking the inverse of this value, we find that the synodic month lasts about 29.53 days.
Why is the Synodic Month longer than the Sidereal Month?
When the moon completes one orbit around the Earth in a sidereal cycle, the Earth has already moved forward in its orbit around the Sun. As a result, the moon needs about 2.2 additional days to realign with the Sun and show the same phase again. Here are the 8 phases of the moon. The synodic month is the time it takes the moon to go through all its phases and return to the same one. This could be from new moon to new moon, first quarter to first quarter, or full moon to full moon. In this example, we'll start with a full moon. As the moon orbits the Earth, it moves through all its phases until it reaches the full moon again, completing a lunar cycle. The synodic month is important because it allows us to predict the phases of the moon, which has been essential for the organization of time in many cultures throughout history. Thanks to this lunar cycle, lunar calendars were developed to organize agricultural activities, festivities, and religious events. A clear example is the Islamic calendar, still in use today, which is completely based on lunar cycles following the Synodic Month. Tropical Month. A tropical lunar month refers to the period the moon takes to complete one orbit and return to the same position relative to the vernal equinox. What's the vernal equinox? This image shows the Earth at the center of the celestial sphere. The blue plane around it represents the celestial equator. It's intersected by another plane called the ecliptic, which represents the apparent path the sun takes across the sky during the year. Observe how the ecliptic and the celestial equator meet, traced by the fuchsia line. The intersection points are highly significant. One of these is the vernal equinox, also called the first point of Aries. This point denotes a precise moment the sun moves across the celestial equator from south to north. This takes place once every year during the March equinox and marks the start of spring in the northern hemisphere. And just so you know, vernal comes from Latin, meaning spring. At the opposite end of the fusion line lies the second intersection point. It marks the moment when the sun crosses the celestial equator from north to south during the September equinox, announcing the arrival of autumn in the northern hemisphere. Now you know what the vernal equinox is, a key reference in astronomy. This image shows how the vernal equinox relates to the zodiac constellations. As we saw earlier, the vernal equinox marks the beginning of spring. But did you know that this point isn't fixed in the sky? Due to a phenomenon called the precession of the equinoxes, Earth's axis slowly wobbles like a spinning top, causing the vernal equinox to gradually shift through the constellations. This cosmic cycle takes about 25,800 years to complete. Long ago, the vernal equinox was located in the constellation of Aries, hence the name First Point of Aries. Over the centuries, however, it has shifted, and today lies in the constellation of Pisces, slowly moving towards Aquarius. Thousands of years from now, the vernal equinox will have moved far enough to return to Aries. In this image, we see the Earth and the Moon in a yellow arrow pointing to a location in space. That location is the vernal equinox, the reference point used to measure the tropical lunar month. It defines a direction extending out into space. A tropical lunar month is the time the moon takes to return to the same position relative to the vernal equinox. We can estimate the length of the tropical month using the following formula. This represents the frequency of the sidereal month. This shows the frequency of the precession of the equinoxes, a cycle that takes roughly 25,800 years to complete. So, by adding both frequencies, we obtain the frequency of the tropical lunar month. By taking the inverse, we get the length of the tropical lunar month. Notice that the tropical month is slightly shorter than the sidereal month. Why? It's because the precession of the equinoxes makes the vernal equinox move slowly backward in what we call a retrograde motion. So the moon doesn't have to travel quite as far to reach the same point again. The difference between the sidereal and tropical month is about 7 seconds per lunar cycle. Although small, this difference is significant. Consider this. Over a century, the cumulative difference is approximately 15 hours. After 1,000 years, the cumulative difference is approximately 6 days. Across 10,000 years, this discrepancy would lead to a deviation of roughly 60 days in astronomical calculations, equivalent to 2 entire months. It is worth noting that even minor cumulative deviations can lead to significant repercussions over time. This was the case with the Julian calendar. Around 2,000 years ago, the Julian calendar made a slight miscalculations in the length of the tropical year. As the centuries passed, this caused the seasons to gradually drift from their original dates. In 1582, Pope Gregory XIII corrected this by removing 10 days from the calendar and adjusting the leap year rules, giving rise to the Gregorian calendar, used worldwide today. Imagine it's the year 25,000 AD, and Americans are celebrating Christmas in the middle of summer because the calendar has drifted so much. Thanks to the Gregorian reform, the seasons remain correctly aligned with the calendar, keeping December in winter as intended. This is why the tropical lunar month, tied to the vernal equinox, is so important. It helps us see the connection between lunar cycles and the seasons, revealing how celestial movements influence long-term weather patterns. Anomalistic Month. As the moon moves around the Earth, it doesn't follow a perfect circle. Instead, its orbit is an ellipse, so there are moments when the moon is closer to Earth and moments when it's farther away. The apsides are the extreme points of an elliptical orbit. They mark the positions where the orbiting body reaches its maximum and minimum distance from the central body. These 2 points are connected by an imaginary line called the line of apsides, which defines the orientation of the orbit in space. When it comes to the moon, apogee is the point in its orbit where it is farthest from Earth, and perigee is the point where it is closest. However, the line of apsides does not remain static. The combined gravitational forces of the Earth and the Sun cause the Moon's elliptical orbit to slowly change its orientation in space, moving the positions of perigee and apogee over time. This phenomenon is known as apsidal precession. Apsidal precession of the Moon refers to the slow and gradual turning of its elliptical orbit around Earth. A full cycle of this rotation takes about 8.85 years. As a result, the times when the Moon is at perigee or apogee change over time. The anomalistic month is a period it takes the Moon to orbit the Earth and return to its closest point, called perigee. Put simply, it is a period during which the Moon moves from one perigee to the next. The duration of the anomalistic month can be calculated using the following formula. This represents the frequency of the sidereal month. This represents the frequency of the Moon's apsidal precession, the gradual rotation of the line of apsides in its orbit. Subtracting the two values gives us the frequency of the anomalistic month. By taking the inverse of the result, we obtain the length of the Anomalistic Month, which is approximately 27.55 days. As you may notice, it's slightly longer than the Sidereal Month. Why is that? This is because absolute precession moves the perigee in the same direction as the Moon moves along its orbit. Therefore, the Moon must travel a slightly longer distance to reach the next perigee. The study of the Anomalistic Month is important because it allows us to precisely predict when the Moon will reach perigee or apogee in the future. This helps us understand why the Moon's apparent size changes throughout the month. When the Moon reaches perigee, its closest point to Earth, and it is in the full moon phase, it appears larger and brighter. This is because the shorter distance increases both its apparent size and the intensity of the light it reflects. This phenomenon is known as a supermoon, a celestial event that lights up our nights with exceptional brightness. The Anomalistic Month is also key to understanding the Moon's influence on tides. The gravitational force the Moon exerts on Earth is more intense when the Moon is at perigee, its closest point to our planet. If a new moon or a full moon also occurs at that time, the spring tides become even more extreme. This creates what are known as perigee and spring tides, which are exceptionally high tides. Draconic Month. In order to comprehend the Draconic Month, we must first delve into two key concepts: the lunar nodes and nodal precession. The blue plane represents the ecliptic, which is the path the Earth follows around the Sun. The yellow plane represents the Moon's orbit around the Earth. The orbit of the Moon is not perfectly aligned with the ecliptic, rather, it is inclined by approximately 5 degrees. Consequently, the Moon's orbit intersects the ecliptic at two specific points, known as lunar nodes. When the Moon crosses the ecliptic, traveling from south to north, that is the ascending node. Conversely, the point where it crosses from north to south is known as the descending node. This inclination explains why eclipses do not occur every month. Eclipses only occur when the Moon is close to one of these nodes. Note that the lunar nodes are not stationary. Due to gravitational perturbations, mainly from the Sun, these nodes slowly move in a retrograde direction, that is, opposite to the Moon's motion. This gradual shift of the nodes is known as nodal precession. The full cycle of nodal precession, meaning the time it takes the nodes to complete one full revolution around the ecliptic, is about 18.6 years. By the end of this period, the nodes will have returned approximately to their original positions. The Draconic Month is defined as one revolution of the Moon about its orbit with respect to the ascending nodes. The duration of the Draconic Month can be estimated using the following formula. This represents the frequency of the Sidereal Month. This represents the frequency of nodal precession. A full cycle lasts about 18.6 years. By adding both frequencies, we obtain the frequency of the Draconic Month. The mean length of the synodical period is 27.21 days. Understanding both the Draconic Month and the Synodic Month is essential for predicting the exact time and location of eclipses. as these events require the moon to be simultaneously near a node and in the right phase. Eclipses occur when the Sun, Earth, and Moon align perfectly. An eclipse can only happen when the Moon is near a node, and the new or full Moon coincides at a precise moment. These perfect alignments are very rare, which is why eclipses don't happen every month. So next time you witness an eclipse, just remember, it's a special event, all thanks to a perfect timing in the sky.
Why is it called the Draconic Month?
The word draconic comes from dragon, and its origin is tied to ancient mythology. In ancient times, people carefully observed the sky, but didn't fully understand eclipses. To explain them, many cultures imagine the moon's nodes as the head and tail of a giant celestial dragon. When the sun or the moon passed through one of these nodes, the dragon was believed to devour them, causing an eclipse. In traditions like those of India and China, people even beat drums to scare the dragon away and free the sun or moon. That's why this lunar cycle is called the Draconic Month. Its name carries the memory of those myths and their link to eclipses. So here they are, the 5 lunar months: Sidereal, Synodic, Tropical, Anomalistic, and Draconic. Each one tells a different story about motion, time, and perspective. Now you know how astronomers track the moon. Which of these lunar months surprised you the most? Let me know in the comments. Ready for a challenge? Put your knowledge to the test. This link will take you to the full quiz. Visit Cerebralia.com to check the upcoming moon phases. Did you find this video interesting? Feel free to share it and help spread the knowledge. Thank you!